object with both magnitude and direction is referred to as a vector. A vector can be visualized geometrically as a direct line segment with an arrow pointing in the direction and a length equal to the magnitude of the vectors. The problem is a plane was traveling 480 miles per hour at a heading of 70 degrees. The wind is 70 miles an hour from 160 degrees. Determine the course and the ground speed. The graph will show you where an airplane it was. So let's say that this is our plane. It actually trying to fly in this direction 70 degrees from north. And the magnitude of this vector is 480 miles per hour. That is the airspeed, so 480. That is the airspeed, and the heading wind is 75 miles per hour from 160 degrees. The ground speed is the magnitude of this vector, and the course is going to be the angle of this vector matched with north. Notice that this angle is 70 degrees and this angle is 160 degrees. That means the difference which is this angle is 90 degrees. Now also notice that this line is parallel to this line. So I have two parallel lines cut by a traversal. That means all frontier angle are going to be congruent. That means this is going to be 90 degrees. So right away I can find the magnitude of the ground speed. So I will call that G. G is going to be the magnitude of the ground speed. So observe that 480 power root of 2 plus 75 power root of 2 equals to G power root of 2. So that is 236,025, that is G square. So G is the square root of that, and it 485.8 approximately, and this will be in the same units mile per hours. Right triangle, the tangent of theta. The side opposite over side adjacent. So it's 75 over 480. Tan theta equals 75 over 480. So theta is inverse tangent of 75 over 480. The inverse tangent 75 over 480. 8.9 degrees approximately, and that means that the cos is 70 degrees minus that. So 70 minus 8.9, and the cos is approximately 61.1 degree. So in the end, our cos is 61.1 degree from north, and our ground speed is 485.8 miles per hour.
Introduction of differentiation. Differentiation in mathematics is to determine a function's instantaneous rate of change by focusing on one variable. Velocity is the rate of displacement change over the time, and velocity is the most common example in differentiation question. So using dy dx, we can calculate the rate of change of s over time in relation to y. A function derivative is f prime x equals to dy over dx, where y equals to fx is any function. Any notation can write as f prime x.
Equation for differentiation is the angular displacement theta radius of a flywheel varies with the time t second and follows the equation theta equal 9t squared minus 2t cubed. Determine the angular velocity and acceleration of the flywheels when time t equal to 1 second and the time when the angular acceleration is 0.
So from the question, we can get two problems. So I will explain the first problem. First problem, we need to find the value of the angular velocity and the acceleration. First, the clue given is theta equals to 9t squared minus 2t cubed, and then the t equal to 1, and then the angular velocity. After differentiate the angular displacement, we can get 18t minus 6t squared, and then replace t as 1, and then we can get omega equals to 12 radian per second. And then to find out the angular acceleration, we need to differentiate 2 times the angular displacement 2 times, and then we can get alpha equals to 18 minus 12t radian per second squared, and then replace t as 1, and then alpha equals to 6 radian per second squared. That's all for me. Then I will pass to Farah.
So for the question B is how to find the time when the angular acceleration is 0. So when the angular acceleration is 0, we use the equation from angular velocity and differentiate it into 18 minus 12t equal to 0, and we get the t is 1.5 second. So the time when the angular acceleration is 0 is equal to, so for the question B is,
from the question we can conclude the angular velocity is 12 radian per second, and the angular acceleration is 6 radian per second squared, and the time when the angular acceleration 0 is 1.5 seconds. That's all from differentiation. We will continue with integration.
So, Assalamualaikum warahmatullahi wabarakatuh. The next chapter is about integration. So, I would like to talk about introduction of integrations. This method of adding and summing the parts to find the whole, it also known as a reverse differentiation process. It used to calculate the sum on a large scale, also used for a large addition problems where the limits can reach infinity. This is the question. The population of bacteria colony 3 hours after observation began is found to be changing at the rate dp per dt 200 exponent power of 0.1 t plus 150 exponent power of negative 0.03 t. If the population was 200,000 bacteria when the observation began, what will the population be 12 hours later? So this is a graph about population of bacteria colony after certain hour. What is the problem statement? The problem statement for this question is how to find of bacteria colony after 12 hours. So the population is found by integrate dp and dp per dt that has been given. So this is a solution 1. Because of this equation have two inner functions, so we can assume there are two variables. We use as a integration by substitution to integrate this equation. So firstly, 0.1t we assume as a u, while negative 0.03t as a u primes. And then we differentiate u respect to t and u prime also respect to t. And then we put the dt at the left and other to the right. Left to the right. So, and then we insert into equation. We integrate one by one in this question. So this is solution 1. So this is a solution 1 which we should integrate this dp per dt in order to get the population after 12 hours.
The population is 200,000. When t equal to 0, find the constant c. So pt equal to 200,000. When t, we substitute t equal to 0. So in this equation, we just substitute t equal to 0 and we get constant is 203,000. Find the population of bacteria colony after 12 hours is we can conclude that t equal to 12 and we just take the equation above and substitute t equal to 12, then we get the answer is 206,152.
So at the end of this solution, we knew how many the population of bacteria colony was produced after 12 hours. The population of bacteria colony that produced is around 206,152. With the solution, we knew how to integrate the function that have been given and the value of constant c when t equal to 0. Integration is very useful in our real life, and our life became easier when we apply this integration to solve problems that involve a big number in equation.